Welcome to homework.
All right, we've got some compounds that we've got to consider. We've got four carbon chain aldehyde. We've got a four carbon chain alcohol. We've got a four carbon chain, and we've got an ether with two carbons on each side. That's diethyl ether. And we've got to determine the order of these in increasing solubility in water, least to greatest solubility. So, what we're going to consider is hydrogen bonding. Is it capable of hydrogen bonding? And then is it polar? Great. We also might consider partial hydrogen bonding. We'll talk about what I mean by that in a second. Okay, so to begin with, let's just review hydrogen bonding. If you have an OH on a molecule, then another molecule with either a nitrogen or an oxygen can act as an acceptor for a hydrogen bond, and this is what causes things to be very soluble in water. This network of HOH interacting with other water molecules is what makes water stick together. It's what makes alcohols miscible in water as well. So anything that's capable of both donating a proton or accepting a proton is capable in some way of hydrogen bonding. Now, if the molecule both has an OH, that is, it can act as a proton donor, or it just has an oxygen, which, for example, water is both, then it's fully capable of hydrogen bonding. Alcohols can act as both hydrogen bond donors and acceptors. They have an OH and they have an oxygen, which can accept other H's. So, in terms of most soluble, it's going to be alcohol. None of these other molecules contain an OH. Next, we can look at hydrogen bond accepting ability. Both of these molecules have oxygen, even though they don't have OHs, they still have oxygen. So if a water molecule, for example, interacts with this ketone, you can still get some hydrogen bonding. It just won't be as strong because the hydrogen bond only goes one direction. Great. So both diethyl ether and this ketone are capable of hydrogen bonding. So now what we've got to do is, or both acting as hydrogen bond acceptors, but which is more soluble? Now we can look at polarity. That is, water is a polar molecule, as we know. Protons are positive, oxygen is negative. And we know that this causes a net dipole in the molecule. It's got a negative side and a positive side. So anything with a negative and positive side is going to be pretty soluble in water. So is diethyl ether or is this aldehyde more polar? That's what we've got to determine which will be more soluble in water. Well, it turns out that aldehydes are much more polar than uh, ethers are. You may think of it, if you want to see why, consider that there's a resonance structure of aldehydes in which this double bond becomes a single bond. And so one way of drawing this molecule is, in fact, to draw it with a negative charge on oxygen and a positive charge on carbon. There's no resonance, there's no comparable important resonance structure for the ether. So in terms of polarity, the aldehyde is more polar and therefore more soluble in water. So now we're saying that it goes alcohol, more soluble then the aldehyde, which is more soluble than the ether. What about the alkane? Where does it fit in here? Well, alkanes have no polarity. Carbon-hydrogen bonds are nonpolar, and it has no oxygen to participate in hydrogen bond. So it's incredibly non-soluble in water. So it's the least soluble. So that's the order: alcohol, aldehyde, ether, and alkane.